As I was saying, there is another one library called, you can use it as a enhanced library for. We have already seen something called NumPy, right? Can you tell me what is NumPy? What is the difference between lists and NumPy, Race?
NumPy is number Python, which is fast, convenient, and consumes less memory space compared to list.
Yeah. So lists will not follow the contiguous memory. So this those are all. It will be the scattered method. So it will not be in a right format. So it will take some time, and it will go and check each and every data as a what data type it is, each and every data it will consider. So it will occupy a lot of memories and it will slow. So we have seen the library called import CSV. That library is created using list, and pandas library usually created in numpy. So numpy arrays. So like in that only you can understand which one will be faster. Of course, pandas is way more faster than import CSV. So import CSV will allow you to write some easy code and manual code, so more like whatever you need to do. Of course, you need to write some more codes while comparing with pandas. So pandas can do a lot of, so for say example, we have seen functions and lambda. So what is the difference between them? Function, we can define, we have to use the def keyword following that function name, then parentheses. If you want to pass parameters, you can pass and end up with colon. Then next line, you need to give the indentation block. And whatever you want, you can write over there. And whenever you're calling the function, it is giving the result. Whereas lambda, you can do everything in the same line. Same goes here as well. So import CSV such as a function, formal function, like it is whatever you want to do, you have to do it manually. Whereas pandas, it is way more enhanced. It will do everything in a short way, and it can read millions of data. So whereas import CSV will not work. Okay. So whereas pandas, one of the most important library whenever it comes to the data science. Okay. So here you can see they are giving some kind of explanation about pandas. Pandas is a Python library used to working for data sets. So data structures we have already seen. For example, what kind of data structures we have seen, list, tuple, kind of things. But here it will always data sets is something kind of a bunch of data structures if it is contains. That is we used to call them as a data sets. Okay, it has a function for analyzing, cleaning, exploring, and manipulating data. So I can say more than that. So like not only analyzing, yeah, cleaning, analyzing in the sense reading the data as either whatever the file it is. Either it's a txt file. Here, analyzing. So as I was saying, you can read a JSON file or a CSV file or whatever file you want. You can have Excel file, any file we have option to read in pandas. So that is we the term we used to call them as analyzing and cleaning. Cleaning, one of the most important thing. Okay, so cleaning, like if there is a null data or duplicated data or else damaged data, repeated data is there. We need to standardize and remove the duplicate data and remove that unnecessary things. Everything, if you want to do, pandas will help you to do those things. Replace all the null data with some mean variance. I think you guys already know the mean variance, everything that we have seen in NumPy, right? So using the NumPy mean or whatever it is, we can find out and we can do. Like for example, you have an entire huge column and you just want to find that column holding some of the null data. So what you want to do, you have to, once again, am I audible, Kasana? You there?
Yes, sir, you're audible.
Sure. Yeah, as I was saying, exploring, manipulating data. Manipulating is, I can explain a lot of things. Inner join, outer join, that inner intersection union that we have seen, right? The same concept. We used to call them as a inner join. So inner join is nothing but like if you have a two CSV file, so you just want to find out what and all the common values is there. That is inner join. One like from the left data to right data you need to join, that is left join, or else right to left you need to join, you can use the right join, or else like the entire total CSV file you need to merge, you can use outer join. So this kind of different things we have. So manipulating data, that not that much only. So you can manipulate like filter the particular data, filter the particular column, finding the mean, average, manipulating that we can say a lot of handling the data, right? Like what is the integer type, one column has integers, in the sense if you want to convert the entire column into float, you can possibly do that, and what not, everything you can do with pandas, and same way that we have seen with numpy as well, right? So um, this is are some histories they have given pandas, and it's called panel data. It's converted as a pandas, something like that they have given. So here they are giving something like a why we need to use the pandas. Pandas allows to analyze the big data and make conclusions based on the statistical theory. This is one of the just one of use, like pandas we are using in various areas. Okay, and like for in our case, like we used to do, we used to get 4 million, 5 million data is there. So what we will do, so we will filter some for example, if you have 4 million data in the sense, what we need to do, what we will do, like in that 4 million data there is no address will be there, no address will be there. So we need to take our latitude and longitude and convert that into address. We have a library called GSM or geo code or geopy, something like that. So it will take the latitude and longitude and it will convert it into the address. So that one of the use that I have used, and I've been using the pandas in different various operations. So like I cannot remember all of the things now. Like most of the time, merging the data, reading the JSON file, and converting that into CSV, or else reading the CSV file in that convert it into JSON file, and taking the columns and comparing with another columns, or else we have a list of data in the sense mapping that with the CSV file. I don't know exactly. You guys know what is mapping? Uh, you guys know or not? So, as I was saying, just analyzing big data. This one of the part. Whenever it's come to the manipulation of data, or else you are going to do anything with data, pandas will be more useful. So that's what I'm trying to make a point here. Yeah, of course. We can clean data like whatever the duplicate data, null data, or damaged data, missing data, everything you can clear up with pandas. Okay, and it will give you a data frame. Data frame is nothing representation of data structure. So it will give you the readable data structure. And yeah, that is the reason we everybody used to call pandas as one of the most important thing in data science. Maybe 1 or 2 years before. Nowadays we have a PySpark, Google Go Labs, and what is that? Something Keras, PySpark. So this kind of things. Those are all created based on pandas only. So, whenever it comes to the matter of data science or machine learning or supervised learning or unsupervised learning or natural language processing, everywhere pandas will be more useful. What you can do, I think I have given so much of information about that. So, I think you everybody installed Jupyter notebook, right? You guys are recording the session. Why? Okay, sure. Who's recording? I don't know exactly. I'm not getting the information. Okay. So if you want to install pandas, you can use pip install pandas keyword, and it will get installed. Then after that, what we are seeing here, we have a dictionary. So cars key holding the value, which is a data structure. Passing is also a key which is holding a data structure, and I'm just converting that into a data frame and printing that. So here you can see that data frame easily converts keys as a column name. So as I was saying, um, it will automatically converts the keys as a column name and the data as a column values. So here cars is a column name and BMW, Volvo, Ford as a column data. So that's how it is works. And rows automatically will create. It will create. Else, if you want to give your own row names, we have something called label operation that will help you to do that. Okay, so now I'm importing the pandas. So data frame can easily, this option can easily convert a dictionary into a tabular format. So that is a data frame. So or else we can simply call it as a data frame. Okay, and if I run this, so it is giving like that. So here you can see if you want to add some more thing. So for example, uh, Volkswagen, like that, and I will give a 8 amount of car, and if I run this again one more time, see, right, like this you can give whatever the things, or else if you want to add some more, like what we can add, any idea, anybody? So let's say put prices, price, like that, and here it is holding some of the data. Okay, 5,000, 7,000, and 3,000, and 12,000, like that. Rerun. See, so you have a dictionary and you can convert it into a data frame. That's what this means. And you can check the version of the pandas. That also you can use the double underscore magical method, and it will give you the version of the not only pandas, whatever for numpy or any libraries, you can check the version. So using the version operation. Serious, we have, I remember that I've shown you numpy file, right? So that holding one-dimensional array, two-dimensional array, three-dimensional array, four-dimensional array. So those things are all we have seen. So we have data frame as well as series in pandas. Series means if it is a one-dimensional array, so that we used to call them as a series. So you cannot convert a one-dimensional array into a data frame. That is not possible. So more than one array only you can convert it into a data frame. If it is a only one-dimensional array, in the sense you cannot convert them into data frame, you can convert them into series. So here I'm I have an array. I'm converting that into series, and you can see automatically row has been created. There is no column name, but we are getting the series. Labels. What does labels means? As I was saying, automatically row will be created. So instead of you don't want to get the number of the rows, number count of the rows like that, you can put something like instead of 1 2 3 you can put a b c d x y z or names, anything that you want you can create. So that's where the labels comes to the picture. So if there is nothing defined as a rows, you can give on your own like whatever you want. Okay, so that's what we used to call them as rows. So here indexing, that's possible. I think everybody knows what is indexing, right? If you have a series, you can access the position and it will give you the results that everybody, we have frequently seen these things. So now go to the creating the labels. So I have again this array and I'm giving the index is like indirectly we are giving it as a labels. Okay, so x y z, instead of 1 2 3 it will become as a x y z. So here you can see, and so after run this, so it is giving, so of course instead of x y z you can give abc or whatever names that you want, you can give it. So here I have given x y z, so that is the reason it is become a row, as instead of giving 0 1 2 it is giving x y z. So that's what a label means. And using the index position, you can access the values that already we have seen here only, right? So here we are accessing the, we are calling the row number. So it is written in the proper result. Here we have given the label for the row. So if you call that label, it will automatically return the result. That's it. Nothing bit much. Sure. So that's how it works. So you just want to convert like I already shown you, we can convert a dictionary into a data frame. Whereas if you want to convert a dictionary into a one-dimensional series, you can do that. So here, the dictionary keys holding data structures, we can convert it into as a data frame. So that already we have seen. Okay, so here I'm just trying to convert that as a series instead of giving a data frame. I'm just converted it as a series and I'm printing that. See what it is giving. So here keys will come as a rows and values will comes as a columns. So this is a row, this is a column data, right? So whereas if you convert a formal dictionary into a data frame, what is happening here? Keys will become as a column title, but whereas series will work in the different way, right? I think Kazana, so far you understood or any doubts on this? Is there?
Yes, I'm there, sir. Can you come again?
So far you have any doubts or anybody?
No, sir.
Okay, so the difference between the series and data frame, series will take the keys as a rows, whereas data frame will take the keys as a column names. So that one you need to know. And same as, so here we have series and here we are trying to convert again the same concept. The keys of the dictionary become as the labels. So that's what I'm trying to make a point here. So if you convert a dictionary into a series, that keys will become as a rows and values will become as a column data. Whereas data frames usually used to work with the multi-dimensional tables. So here if you pass a dictionary, that already we have seen, color race will become as a column name, this will become as a column data. So and parent see, so that is the difference between the series and data frames. Why we are seeing this in the sense, one of the most important library that already we have shown, I told you, right, for the data science. So like this is also constant at the file handling, right? So that is the reason after the import CSV library, we are reading the data file handling topic, we are seeing this. So you can catch up, that's the reason. And locate row. So that already we have seen locating a row, we are passing the label of the row and it is written in the result. Instead of that, we can call something called location, and if you can pass the row number and it will return the result. Okay, so here okay, let me comment this, and if I run this, here color is 390, duration 45. So the row number location 2 in the sense this is a calories, this is a duration, so this is are all column names, which means the row number 2 what it will become 390 and 45, because this is the zeroth row, this is the first row, this is the second row. So I'm accessing the second row, that is the reason it is giving the result, and along with the column names and along with the data types, everything. And if you want to filter a particular column, so here we are accessing rows. Instead of, you don't want to access a rows, you just want to access a column, in the sense that also we can do. How we can do then that, like we have created a data frame and store it into the variable, and we are passing the data frame variable, and we are passing the column name, and it is returning the column. See, what is the column? Duration column I'm accessing 50, 40, 45, it is giving. Understood so far? Or any doubts up to this? No, nothing. Okay,
Understood.
that's fine. Okay, so next, named indexes. That now only we have seen, right? Why they are putting again and again same things? Data frame, yeah. Ah, okay, so this is something different. We need to see this. As I was saying, you can convert the dictionary into a data frame, but still it will give a row as a 0, 1, 2. So instead of that, you just want to give your own name of the rows. Of course, you can do that. So calories, duration, we have column names, but we don't have any row names, right? So three data is there. You have to give three names. If you give more or less, it will throw error. You have to go with perfect only. Then only it will give you the proper row name. So day 1, day 2, day 3, because I have three columns, sorry, three rows. So I have to pass three row names. So if I run, so you can see it is giving, instead of that you can give week 1, week 2, week 3, or whatever the name that you want, you can give as an index, and it will go and set as a. The point is, not only the series you can set the labels, even the data frame also you can set the labels. That's what they are trying to make a point here. That's it, nothing but much more. And following that, named indexes. In the data frame, in the series we have seen the I location, and it is written in the data, where here. So I think I location also we have seen somewhere, right? Where is that? I just forgot about that. Yeah, here. So it is a series. Okay, even that is a data frame only, right? So in the data frame, that time we don't have any row name, but this time in here we have row name. So you can use the row name, and it will give you the result. So that is the thing what we are seeing over here. Instead of using the default row name, if you put your row name, you have to call that with that name only, then only you will get the proper result. So day 2 means 338, sorry, 380 and 40. In properly you are getting 380, 40. You can clearly see that. Okay, and following that, load files into a data frame. So this is where exactly the real data science is getting started. So far what we have seen, what is the data frame, what is the series, and how to create, and what is location, accessing data, how to put the labels, what is the rows and columns, how to change the row names, columns, and so far we have seen. Okay, so here is the real data science things will be comes to the picture, because why I'm saying this, data science, whenever you are going to get a data about the company, you will get millions of data, years of data, which means more than the millions of data will be there. Okay, so you cannot write them as a dictionary one by one. If you do that, it will take days or weeks to complete. So that's not even possible. So they will give you the CSV files. So you have to handle the CSV file. So of course you can handle the CSV file using the basic CSV library as well. or else you can simply handle them with pandas as well. So that's which one you are going to use, that's totally up to you. Okay, for here, I am going to try to upload a CSV file to my data frame. Okay, so first we are going to read the entire data and store it into the variable, and then we are going to convert that into a data frame. So here, okay, let me close this. Here you can see I have a test CSV. If I open this, it has around a 10 amount of data. Means 9 rows and one is the column names. And the file name is test CSV. I'm importing pandas as PD, and pd.pandas has something option called read CSV, whereas you have read Excel file, read JSON file, whatnot. What are the data types is there? What are different files you can read. So most of the time we used to do read CSV file and Excel file and JSON file, which means whatever I used to work with. So here I'm putting the test.csv and reading giving CSV. Don't forget this CSV option. So if it is a JSON, you will get read JSON option. If it is Excel, you will get read Excel option. And here CSV. So that is the reason I'm giving the option called read CSV and passing the CSV file name, and read it the data. I'm storing it into the df data frame. So it's not actually data frame. It is just a variable which is holding the entire data about the CSV, and I'm printing the variable just, and it is giving the data. So whereas read CSV file is this is the basic, but here you can see they are giving two string. So what is the difference between directly printing this and two string option in the sense? This test CSV, in case if it is have a millions of data or thousands of data in the sense, you cannot possibly print them using this variable. So what it will do, it will give first 30 rows and last 30 rows, and how much rows are there, how much columns are there, that much only it will return. So you just want to see the entire thousands of code in your terminal, you can use toString. This toString option, toString option will allow you to print the entire CSV file into your terminal. So that is the difference between the basically printing the variable and along with the toString option. Okay, so yeah. But here I have only 8 records, so that is the reason both of them giving the same results. So maximum of rows, 60 rows it can return. So here I have only 8 rows, that is the reason both of them it is giving same results. And max rows, as I was saying, it will return only 60 records. Even if you have thousands of records in the as well, it will take first 30 records and last 30 records, and it will return the data frame. So you just want to you can approach the toString operation, or else you can change the maximum rows of values. For example, I'm importing pandas and options of display maximum rows, how much rows it can display. I just want to check it, and if I check, defaultly it will be set it as a 60. So millions of data also will, even if it is available also, it will take the first 30 records and last 30 records, and it will return. Okay, and how much rows and how much columns, those much details it will return. And you just want to change this 60 into something else. So here in my case, maximum of rows, 4 rows only I need to print, rest of them I don't want to print, like that I'm setting. And again I'm reading the CSV file, and if I run this, and you can clearly see that first 2 records and last 2 records it is returning, and 9 rows and 5 columns, that details also it is returning. Okay, so this is exactly how you can change the maximum reading amount of the file. Hope you guys understood so far, right? Or any doubts so for Kazana or Manisha? Anybody?
Understood, sir.
No doubts, really? What about you, Manisha?
Yes, yes, understood.
Oh, okay. Sure. Okay, so anyway, I will show you one more time what all we have seen. So from the starting to here, so we are first importing, installing pandas using pip install pandas. Then after that we are importing pandas. Of course, you can import it with a short name, has pd, whatever you want, you can import it. That's not a problem. And we are declaring a dictionary, and in the dictionary we are converting that into data frame. So whenever you are converting a dictionary into the data frame, the keys will be take it as a column names, and the data will be take it as a column values. Okay, so basically if you convert a dictionary into the data frame, this is how it is works. Okay, and following that, if you want to check not only pandas, any library, not only pandas, any library, you want to check the version, what kind of a current version of the library, you can use magical method called double underscore version and double underscore. It will give you the version of the library. So one dimensional array, we used to call them as a series. Okay, so you cannot convert our multiple dimensional arrays as a series. Sorry, arrays should be as a one dimensional array. So then only you can convert it as a series. The difference between the series and data frames maximum it will give you the matrix operation. Here it will give you only one row. So here you can see it is giving around 3 into 4 data matrix it is giving. In the numpy only we have seen matrix, right? What is 2 into matrix, 3 into 2 matrix, what is the size of a matrix, everything, right? So that's the difference between the data frame and series. Okay, and labels we have seen. So once we have declared the series, it will automatically give you the rows count. So instead of, you don't want to get to know the rows count, you want to put some labels for each rows. We have some operation called labels. So that labels, you can give the labels using the index keyword operation, and it will go and set for each rows, and you can access them based on the label the particular row. For example, if I want to access 2, I can call z. For access 1, I can call x. Like that. Here I just want to access 7, that is the reason I'm passing y, and see, it is giving the result. Okay, so as well as if you have a dictionary, you just want to convert that into series, that is also can be possible. So here, unlike the data frame, the key values, they are not taking it as a column names, but they are taking it as a row name. So in the data frame, each and every keys will be take over and as a table name, column name. Here, it is taking it as a row name. So there is a difference between them. Okay, and following that, here that's what they are mentioning. Like if you convert a dictionary into the series, it will take the key values as a row name, whereas a data frame will take it as a column name. Okay, and here again what they are converting, yeah, putting the label. Okay, so here index day 1, day 2, like that only they are calling, and that much only it is returning. So day 3, day 2 they haven't called, so that is the reason it is not returned here. Whereas data frames, it's like it will create a matrix for you. So if you pass a dictionary, it will take the keys as a column name and the entire data as a column. So here if you didn't pass a data structure, instead of that if you pass a data type, it will no, it will not support, it will not able to convert that as a data frame. If you want, you can try that as well. Instead of putting it as a list, if you pass only one value, what will happen, if you can check it. Okay, so that will throw you error. And whereas location of the row, so you have created a you have read stored, which means you have converted a dictionary into a data frame. You can you can call something called LOC, and you can pass the row data, and it will give you the row data. So here second row 39045 is written, and that is how you can access rows. Whereas if you want to access the column, you can use the column name with the data frame, and it will give you the entire column. That's what happening here. And following that, named indexes, even not only for the series, you cannot change the in the series only. So I'm confusing, right? Yeah. So not only you can change the row name with in the data frame as well as in the series as well. So here we have seen how to change the row name with the series, which is labeling. Whereas you are creating a data frame, there also you can put a row name. So that's what happens here. So named indexing, or else we can call them as labels. And after you are creating the data frame also, you can access the row name, and it will give you the result. And finally, what we have seen, uploading a file and storing into the data frame variable, and we are printing it. And we have seen what is the toString and formal printing. So this method will give you the limited data, and rest of them it will give it as a this much rows, this much columns is there, like that it will return. Whereas toString, it will return entire data about the CSV file into your terminal. That is the difference between them. And following that, maximum rows, how to change the maximum rows. Defaultly it will be set as a 60. You just want to change it into 4000 or entire data, or like a 4 or whatever number you want, you can set it, and you can read a CSV file, and it will work based on that. So this is how you can basically work with the CSV files, and you can do a lot more with that, that we will see in the next class. So read JSON also we will see in the next class. I think this file I already shared with you, right? Or didn't I, Kazana?
Yet to share, sir.
Haven't shared, really. I just shared that, right? Whatever, I will share it one more time, not a problem. So you got your file into your chat box. Go and work on this, because this is something important whoever want to become as a data